Hello everyone, welcome to this video. Today I am going to explain you a important algorithm which is both important for your theory as well as practicals. Okay, in theory, as I have told you, this question, if asked, can fetch you marks somewhere between 5 to 10 marks. Okay, and in the practicals, you may get this question for whole 20 marks. So understand this very carefully, and in this video I am going to explain all the basic terms that are necessary for you to understand the algorithm. The terms like infix, postfix, left parenthesis, right parenthesis, operator, operand, all of them I'm going to explain, and I'm going to take an example and trace this algorithm and show you how you will get the result. And after this I am also going to explain you the code for this algorithm, and I'm going to execute with an example and show you. Okay, now without wasting much time, let's get into the algorithm. If you look at this algorithm, this is having two parameters. Okay, one is q and p. What is q? Q is a arithmetic expression written in infix notation. You should know what is a infix notation. Infix, the name itself says, if I got a plus b, I have got the operator fixed in between a and b. And here, if you observe carefully, this b and a are called operands. Okay, they are called operands, and the plus symbol is called operator. There are different operators. You must be knowing this one: minus, plus, divided by, into, power. They all are called operators. And operands are nothing but the alphabets in this case, and in some cases they can be numbers also. Fine. Now we'll go to the next concept, that is, this algorithm finds the equivalent postfix expression p. Now you might have understood q is nothing but the infix expression that is given by the user, and p is nothing but the postfix expression that is will be the output of this algorithm. Okay, so now we'll try to trace this particular algorithm. For tracing this, we'll require some things. We'll require a question. Let me take a question. I'll take a simple question: 5 into 4 plus 3. Okay, this is very simple question. We'll try to trace this one. For tracing this, what we will do, we need a tabular column. You see, in this question we are going to use stack. I think all of you know what is stack. Stack is a data structure which follows first in first out or last in last out. Okay, now we'll just try to draw a table for our question. Here we'll be having step. Okay, and here the scanned symbols, and then next we'll be having the stack here, and we'll be having the expression p. P is nothing but the postfix expression that we will get it from the algorithm. Fine. Now let me take the first symbol, step 1. In the step 1 I'm going to take the first symbol 5. Now try to read the algorithm and just try to identify what you will do this 5, whether you will add it to the stack or you will add it to the p. Okay, it is clearly mentioned here. But before doing that, there are some things in the algorithm, step 1, step 2, just try to read them. Push, this is a left parenthesis. You need to understand this is called as left parenthesis, this is a right parenthesis. Okay, you should know this part. Now push left parenthesis onto the stack. This is our stack. I am just going to push left parenthesis and then add right parenthesis to the end of the queue. This is our queue. I am going to add a right parenthesis here. You will understand why I am doing this one. Why the algorithm says like this, you will understand at the end. Okay. Scan queue from left to right. Repeat step 3 to 6 for each element of the queue. You are going to scan the elements from left to right. This is your left and this is your right. You are going to scan the elements from here to here one by one. And then if a left parenthesis is encountered, push it to the stack. If you are finding a left parenthesis, this parenthesis, what you need to do? Just push it to the stack. And then, okay, before that we have got step 3. If an operand is encountered, add it to P. If you are finding a operand, I have told you, now this 5 is a operand, you are going to add it to the P, right? And then if a left parenthesis is encountered, push it to the stack. If you are finding a parenthesis like this, you are going to push it to the stack. Okay. But what is the next symbol? After taking 5, I have got star as the next symbol, that is the multiplication symbol. Now you need to observe this carefully. If a operator, this is a placeholder for a operator, it means this can act as any of the operators, is encountered, then repeatedly pop from the stack and add it to P. Repeatedly pop from the stack and add it to P. Each operator which has the same precedence or higher precedence than the scanned operator. Means you need to find the precedence of this operator and then this operator. If there is any operator, you need to find the precedence of this. If you feel or if you find that this particular operator which is on the stack, if it is having higher precedence or equal precedence than this, you are going to pop the elements one by one and add it to P. Okay, that you will understand bit later. But as of now, I don't have any of the operators in the stack, so I'll simply push it onto the stack, because if you read this, add the operator to the stack. So I have added, I have got 5 in my expression. Now what is the third one? Third is left parenthesis. If you read this part, if a left parenthesis encountered, push it to the stack. So we have got left parenthesis, a star, and then again a left parenthesis and 5. Then after this, I have got 4. You take 4 here. Then since 4 is a operand, what the procedure says? If it is a operand, then add it to P. So I am going to add this 4 to P. So 5 and 4. Fine. Then the next one, it is plus. If it is an operator, you are going to identify, you can observe it, if it is an operator, then repeatedly pop from the stack if there is something on the top of the stack, if there is an operator on the stack. Now if this is the case, then you are going to find the precedence of this, but we do not have that case here. So what you will do, you will have simply plus on the top of the stack. It means we have pushed this plus on the stack, we have followed this one, and then 5 4. Then the sixth one, after plus I have got 3. Since 3 is a operand, just add it into the expression. 5 4 3. Now next, I have got a closing bracket after 3. If I am finding a right parenthesis, I have got a step, observe here, the sixth step says, if I have got a right parenthesis, then repeatedly pop from the stack and add it to P. When add it to P, each operator, means you need to pop the element from the stack and add it to P. Until when? Until a left parenthesis encountered. In this case, left parenthesis here only. So if I find a right parenthesis, just go on popping this one and adding this to the stack. So what happens? I got this star. Since I have encountered this one, I'm going to have 5 4 3 and plus. And then remove the left parenthesis. Do not add it to the P. See, this was a left parenthesis. You just discard it. You need not add it to P. All right. And then the last one, again, I have got a right parenthesis. As this step says, if you find a right parenthesis, just go on popping all the elements from the stack until you find or encounter a left parenthesis. This is a left parenthesis. So we are left with this star. Just pop it and add it. So 5, 4, 3 plus star. Okay. And this was a very simple example. And for the same example, I'm going to execute the program and show you. So you can observe carefully, this 5, 4, 3 plus star is going to be our P. What is this P? P is nothing but the postfix expression. Fine. Now I'll explain you. If you have understood this algorithm clearly, then you will understand the program very well. Fine. Now we'll come to the program. In this program, I am going to use 3 header file. Now we're checking whether it is a, so this one is used for printf and scanf. All of you know this one. Okay. If you see the next one, ctype.h, this is actually used to identify whether a character is alphabet, alphabet or a number. Whether it is a alphabet or a number. Is alphabet or num? This function will return true if it is a alphabet or num, else it is false. Okay. Then string.h, you all know this one, you have studied already in string chapter, that strlen. If you want to use strlen function, you must have a header file string.h. Okay. Now we are defining the size 100. We are defining the size of what? You will understand here. I am going to define the size 100 for our stack. You all know that we will be using a stack here. In this example, you can observe this is going to be actually our stack, and here we are at max we are using only 4 bytes. Okay, 4 bytes for storing, but this one is going to reserve almost 100 bytes. Since it is a character, each character takes 1 byte, and therefore this is going to reserve 100 bytes, right? And then next, top is equal to -1. This is because you know that we'll be having a stack, and in this stack top will be pointing to the first element. If the stack is empty, actually this top will be pointing to -1. As soon as you add an element here, if I add 4 here, then the top value becomes 0, right? It means the stack top value will be automatically what? 4, because it is stack 0 equal to 4, right? So you should understand initially the top value will be -1, and you can observe that these both the variables are declared globally. They are not declared in any of the functions. Okay. Now we have got one function here. This is a push function. This function is going to take C as a parameter. Okay. It means it is going to take one input and going to increase the value of the top and add that value to the stack. Now observe carefully here. Imagine this is our stack. I have got 5, 3, and at present top is pointing to this one, right? So if it is 0 index, it is first index. So now top value will be 1. Now if I want to push an element in this, push 7. If you want to push 7, what will happen is, you can observe here, first the top is incremented. What is the value of top? Initially it is 1. Now 1 plus 1 is equal to 2. So top becomes 2. Then stack top means what? Stack 2 is equal to 7. See the character, it is 7. You are going to add it to this part. Fine. Now it will be very clear. As soon as this value is set, it will be 7, and then the top will be pointing to this. This push is nothing but implementation of stack using arrays. Okay, in that problem, you might have seen this code, exactly same code. Okay, now we'll go for the pop element. We have got two cases here. One, if top is equal to -1, it means you are trying to delete a element from the stack when the top is pointing to -1. This is 0, 1, 2, 3. In this case, actually you will have a underflow case. Here you will have what? Underflow case. Fine. And if not, see, if it is a underflow case, then it is going to return from this one. Else, it is going to return stack top minus minus. It means if there are some elements here, 5, 3, 7, now at present top value will be equal to 2. And if you try to pop a element, it is going to set stack value to what? Top minus minus. It means you are going to reduce the top value by 1, and that's why top value becomes, so top will be equal to what? Minus top minus 1, that is 2 minus 1 is equal to 1. Now if top value becomes 1, top will be pointing to this one. So automatically in the stack the top element will be 3. This way popping takes place. If it is returning a value, you can observe here stack contains all the character values. That's why the return type of this function is char. Fine. Now we'll come to the precedence. As you know that whenever you encounter a operator in the scanned symbol, okay, in the scanned symbol you find a operator, and there is a operator on the top of the stack. Okay, see here in this case, if you had a plus here and if you had a into, you need to find the precedence of these both. And if it is a lower precedence, you are going to add it here. If it is a higher precedence, then you are going to pop it from here and add it here, and then add it here. Okay, this is the procedure that is written in the algorithm, right? So the same thing is done. To do that, we have written a function, and this function is going to return an integer. It says that this precedence function is going to take one parameter, okay, and that will be a character. OP is nothing but operator. If operator is equal to power symbol, then it is going to return 3. If operator is equal to a star symbol or a division symbol, multiplication or division, it is going to return 2. If it is plus minus, then it is going to return 1, else it is going to return 0. Okay, so you can observe carefully, precedence of into will be greater than precedence of plus, right? So what is the value of this one? Precedence of star is 2 is greater than, the precedence of star is 2, and then the precedence value of plus is 1. This is correct. In this way, actually, whenever you call this function, it is going to return you an integer depending upon the operator that you are passing here. Fine. Now we'll come to the next one, which is a very important function, and this function exactly has all the steps that are there in the algorithm. Okay. Now you see carefully, this is returning void. It means this, it is returning nothing. Infix to postfix, this function name is infix to postfix. It is not compulsory that it should be infix to postfix only. You can write any function name, and then it is going to take two arrays of characters. Infix is going to be a array, and then character. This postfix also going to be a array. Both of these array of characters. Okay. If you just write char postfix, it means you will have to pass only one character here. But if you write this symbol, it means you can pass array itself. Okay. Now when you call this function, we are going to initialize two integers. You can observe carefully. We have initialized I and j. You will understand why we have initialized two. and then you have got a character C. Now what is the first step? Since the algorithm says you are going to traverse from left to right, so left to right, we will be having in the infix expression, we'll be having a b c d. It is 0 1 2 3 4. You need to read each and every element. That's why I'm running a for loop from 0 to infix of I not equal to slash 0. It means this is null. Means we will try to check when you are scanning this character array. You know that each and every string will have null character at the end. That's why we'll try to check that one. And then I plus plus. This syntax is known to you all. Just a for loop. Now what is the first step? You are going to take the first element. Now infix 0 initially. I value is 0, so infix 0 is equal to C. It means if you have entered 5 plus 4, 5 into 4, then initially C value will be 5. Okay, and then automatically the value will be checked here is alnum. As I have told you, this will check whether it is a alphabet or number. If it is a alphabet or number, now is alnum 5. What this is going to return? Since it is a integer or number, it is going to return true. Then automatically that particular value will be added to what? Postfix expression. And this j initially it will be 0, and now it becomes 1. Okay, so postfix 0 is equal to 5. Then next, if c is equal to, see, we have got all else if statements, else. Okay, after that we are going to find if there are some elements remaining in the stack. You need to pop them one by one and add it into the postfix. As the last statement says, you can see here, if you want to exit from the loop, what you will do, you will try to add all the operators that are remaining in the stack will be added to the end. Okay, so that file loop is written because of that. Now if you come here, if you see, if opening parenthesis push to stack, same as it is written in the algorithm. And then if closing parenthesis pop until a right a left parenthesis is found, same that we have done recently. And try to understand this simple syntax. In this what happens, it is going to check top of the stack is equal to left parenthesis. Till it finds this, it is going to pop the element and add it to the postfix expression. Okay, as we have done schematically on the top. Okay, then at the end it is going to pop a left parenthesis. As they have said, we have to discard the left parenthesis and create a postfix. And then this is very important. Here we are going to check the precedence of the top of the element and then the precedence of the character. If c is equal to plus, we'll compare this c, precedence of this c, with the top element of the stack. Okay, if it is into and if it is plus. Okay, if on the top of the stack if you have got into and this is plus, precedence of plus is going to return you what? It is going to return you 2. All right, no, it is going to return 1. You can see here, precedence of plus is going to return you 1, right? So precedence of plus is going to return you 1, and then this is going to return 2. So 2 is greater than or equal to 1. Yes, that is true. In this case, we are going to pop the element from the stack and add it to the postfix. Else, in the else part, we are going to push the element to the stack. Okay, at the end, this has to be done. Fine. This way, whatever is written in the algorithm is written in this particular function. This function is the most important function in all of this. and others like finding the precedence. We have written a function here, finding the precedence function, that is just to know what is the precedence of each of the operators. And then you can see what is there in the main function. We have got infix size, means it is going to create an infix of size 100, postfix of size 100. And then we are going to have a enter an infix expression. This will be printed on the console, and as soon as it is printed you can enter a string, and that string will be stored in infix. Okay, infix expression without spaces. You need to enter the expression without spaces. You need to remember this. Convert to the postfix. For converting to the postfix, you simply need to call the function, that is infix to postfix expression. You need to pass infix and the postfix, whatever you have created here. You have created two arrays, you need to pass them to this function, and this function is going to form the postfix expression, and that will be printed here. Postfix expression, very simple program. But if you understand the algorithm carefully, you will be able to write this code, not difficult at all. Okay, we'll go for the execution. Whatever I have explained here, the same thing is written here. You can see the header files, and we have defined, and then we have got a stack. We have defined the memory for stack and a top element -1 initialized, and then push function, pop function, this is precedence function. And for infix function, infix to postfix expression, we are directly using the algorithm step by step. Okay, you can observe this till here. And then you can see at the end we are going to add null to terminate the postfix string. Since it is a string, it should have /0. And then after that we are going to have a main function. In this I have explained each and every line. Fine, we'll try to execute our question that we had here. You can see I have got 5 star 4 plus 3. Now I try to execute this program, gcc, then the file name infix to postfix, right? Then dot slash a for execution. It will ask you to enter a infix expression 5 into, remember without spaces you are going to enter 4 plus 3. So 5 4 3 plus into 5 4 3 plus into. Okay, in this way you can enter any of the infix expression and get output as a postfix expression. Okay, thank you.